Hello students, in, a, in our previous videos we already completed real numbers in number system and polynomials. Now in this video I will explain the chapter 3 pair of linear equations in two variables. It is chapter 3. Pair of linear equations in two variables. Okay. Now what is the standard form of linear equation? First let us write a standard form of linear equation. The standard form of linear equation is ax plus by plus c is equal to 0, where a is the coefficient of variable x, b is the coefficient of variable y, and c is the constant term. Pair of linear equations in two variables, so two variables are x and y. Now pair of means there must be two equations. So we are going to represent the two equations as a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. Equation 1 and equation 2. Now first we have to see what will be the type of the equations, how are they related, and how to find that out. Two linear equations can be intersecting at a single point. Second case, parallel to each other. And third case is two lines are coincident lines. So these are the different types of two lines can be. If two lines intersect each other at one point or many points, then we can find out the coordinates of those points. If two lines are parallel to each other, there is no point of intersection exists there, and said that lines have no solution. Now number 1, two lines can be intersecting lines. So intersecting lines. First, we have to test the solvability of the lines. That is, before making the solution, we have to test whether solution of those two lines exist or do not exist. Now, intersecting lines. Intersecting lines means, say, this is the first line and it is represented as a1x plus b1y plus c1 is equal to 0. And another line is, it is like this. Say the equation of this line is a2x plus b2y plus c2 is equal to 0. So this point is the point of intersection. This is called point of intersection. Point of intersection. Now, if two lines are intersecting lines, then they must satisfy. That is, if a1 by a2 not equal to b1 by b2, lines are intersecting. Lines are intersecting. Intersecting at a single point. At a single point. Therefore, lines are consistent. Lines are consistent and unique solution. Unique solution. Unique solution means not more than one solution. Unique solution exists. So, before making the solution, we will test if it is a1 by a2 not equal to b1 by b2, then it is said that lines are intersecting at a single point, lines are consistent and unique solution exists. Now, case 2, parallel lines. Parallel lines. Now, parallel line means, say, this is one line and this is another line. This line is represented by a1x plus b1y plus c1 is equal to 0. And this line is a2x plus b2y plus c2 is equal to 0. Now, as these two lines are parallel to each other, solution means actually what? Solution means finding out the coordinates of the common point of the two or more lines. As these two lines never intersect, so they don't have any solution. Then what is the condition? That is, if a1 by a2 is equal to b1 by b2 not equal to c1 by c2. Not equal to c1 by c2. Lines are parallel. lines are parallel. Lines are inconsistent. Lines are inconsistent. And they do not have any solution. That is, solution is not possible. Now the third case. What is the third case? Coincident lines. Coincident lines. Coincident lines means that is lines overlap each other. Say the line AB is represented by A1x plus B1y plus C1 is equal to 0. And say CD is equal to A2x plus B2y plus C2 is equal to 0. Then if A1 by A2 is equal to B1 by B2 is equal to C1 by C2, lines are coincident. So coincident means they intersect each other at so many points. So they have infinitely many solutions. That is, the lines are consistent and having infinitely many solutions. Infinitely many solutions. So again, let us recall what we have learned. If A1 by A2 not equal to B1 by B2, lines are intersecting at a single point. If A1 by A2 is equal to B1 by B2, not equal to C1 by C2, lines are parallel. And if it is A1 by A2 is equal to B1 by B2 is equal to C1 by C2, lines are coincident. That is, the lines are consistent, but they have infinitely many solutions. So before making a solution, we must justify whether there is lines are solvable or not. If solution is possible, that is unique solution or infinitely many solution, whatever may be, it is said the lines are solvable. But in our syllabus, solution we only mean unique solution. By solution we only mean the unique solution. What I have discussed, I want to explain those again, taking examples. Suppose first I have taken two lines, 3x minus 5y plus 12 is equal to 0, and 7x minus 2y plus 9 is equal to 0. If we compare this line with the first line, equation of the first line, that is a1x plus b1y plus c1 is equal to 0, we have a1 is equal to 3, b1 is equal to minus 5, c1 is equal to 12, a2 is equal to 7, b2 is equal to minus 2, c2 is equal to 9. Now a1 by a2 is equal to what? 3 by 7. b1 by b2 is equal to what? Minus 5 by minus 2. Hence, what we get? a1 by a2 is not equal to b1 by b2. Therefore, lines are intersecting and unique solution exists. Therefore, lines are intersecting and unique solution exists. Now for the solution we will use different methods to find out the value of x and y. Next, I am taking another pair of lines. Another pair of lines, say 2x minus 5y minus 5 is equal to 0 and 4x minus 6y minus 7 is equal to 0. Again, let us compare these equations with the standard form of first equation and the second equation in terms of a1, a2, b1, b2, c1, c2. Then we will have a1 is equal to 2, b1 is equal to minus 5, b1 is equal to, this is not 5, this is 3. So b1 is equal to minus 3 and c1 is equal to minus 5. a2 is equal to 4, b2 is equal to minus 6, c2 is equal to minus 7. Now a1 by a2 is equal to 2 by 4, that is equal to 1 by 2. b1 by b2 is equal to minus 3 by minus 6, that is equal to 1 by 2. c1 by c2 is equal to minus 5 by minus 7, that is equal to 5 by 7. So what we have seen, therefore we have a1 by a2 is equal to b1 by b2 is equal to half, but not equal to c1 by c2. Therefore lines are parallel. And then what happened? As the lines are parallel, no solution. Therefore no solution means lines are inconsistent. Now for the third one, let us take one example. Now for the third one, say lines are, that is 2x minus 3y minus 5 is equal to 0, 6x minus 9y minus 15 is equal to 0. Now what happens? If we compare these equations with the standard form of the given equations, then we will have a1 is equal to 2, b1 is equal to -3, c1 is equal to -5, a2 is equal to 6, b2 is equal to -9, c2 is equal to -15. Now a1 by a2 is equal to 2 by 6, that is equal to 1 by 3. b1 by b2 is equal to -3 by -9, that is equal to 1 by 3. c1 by c2 is equal to -5 by -15, that is equal to 1 by 3. Therefore, what we have seen, a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Then this condition is satisfied. This condition is satisfied. Which one? The third condition, that is a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Third condition is satisfied, means the lines are coincident. So lines are coincident and have no solution, that is sorry, and have infinitely many solutions. So up to this for today.